Hello students, good morning. Today we are going to discuss topic cardiac cycle. Till our previous classes like cardiac impulse, ECG, we studied electrical events occurring in the heart. Okay, today uh, we'll start with the mechanical events occurring in the heart. So under cardiac cycle, mainly we have to focus on what are the mechanical events occurring in the heart. And you know, the mechanical events in the heart are systole, diastole, and what events occurring during the systole, what events are occurring during the diastole, then pressure and volume changes during the cardiac cycle, that all will be studied under the cardiac cycle. Okay, we'll go there. Before to that, what is a competency of this topic? So at the end of this lecture, you should be able to discuss and to discuss the events occurring during cardiac cycle. You should be able to tell what are the events occurring during the cardiac cycle. Okay, it's a competency. And exam point of view, if you see the exam point of view, these questions are popular on cardiac cycle. It's a long question, always ask. First, define cardiac cycle. So under this, you define the cardiac cycle, then write some introduction about the cardiac cycle. What is cardiac cycle time? Then what are the then continue with describe the various events of the cardiac cycle. So make the list of various events and explain one by one. Okay, and it is also continued with also describe the pressure and volume changes occurring during the cardiac cycle. So in this first lecture, in this first question, here events first you have to explain and then concentrate on pressure and volume changes. Okay, now see the second question. Second question is also nowadays very popular. It's asked many times, and here they have concentrated on pressure and volume changes during the cardiac cycle. Particularly, it is a left ventricular pressure and volume changes during the cardiac cycle. Okay, uh, time to time I will tell how will you write the answer. Now we'll continue what we have to study under the cardiac cycle. Here, first, what is cardiac cycle? That is a definition of the cardiac cycle. You know, definition is changes that occur in the heart during one beat are repeated in same order in the next beat. Okay, again try to understand what changes occurring during one beat. Changes means, for example, systole, diastole, then whatever the pressure changes, like mechanical events, systole and diastole, then pressure and volume changes. Then if you see the electrical events like depolarization, repolarization, then it gives one ECG, like it includes 5 waves and intervals and segments. So all these changes occurs in one beat are repeated in same order to the next beat. Okay, this cyclical repetition of changes in the heart from beat to beat is called the cardiac cycle. It is a simple definition. In other words, I will tell you the changes occurring in the heart, that is during one beat. Changes occurring in the heart during one beat is a one cycle, one cardiac cycle, and it repeats same order in the next beat. Okay, so it is called the cardiac cycle. And if you see the cardiac cycle time, that is it is a period between the beginning of first beat to the next beat, and that period is cardiac cycle time. Time required for one cardiac cycle, it is on an average it is 0.8 second. Okay, so it takes 0.8 second, but we have around two lectures on cardiac cycle. So what is taking place in 0.8 second? We are going to study for the 1.5 hour of the under the two lectures. Okay, so here now coming to the point how it is calculated. Okay, so cardiac cycle time means it is a time required for one complete cycle, and it is calculated simply 1 minute, that is a 60 second, divided by heart rate. For example, at this moment your heart rate is 75, then 60 divided by 75, your cardiac cycle time is 0.8 second. Okay, now here cardiac cycle time is inversely proportional to the heart rate. Increase in heart rate, decrease in cardiac cycle time. Okay, so simply we can say that each event in the cardiac cycle is repeated after every 8 seconds, because it's cyclical repetition. Okay, and that is repetition is there after every 8 seconds. Okay, now students, see the, will continue here. Make out the list of events occurring during cardiac cycle. We'll concentrate because you know the question is there, what events occurring, discuss and describe what events occurring during the cardiac cycle. So see the events in simple language, that there are two events. The major event, that is a systole and diastole. The systole of atria, diastole of atria, systole of ventricle, diastole of ventricle, and like this, if we take together, it becomes four events: two atrial and two ventricular, atrial systole, atrial diastole, atrial ventricular systole, and ventricular diastole. Okay, now see the list of atria and ventricular events with the time required. Okay, so here see the list and its time, how much time is required. Now I told that total cardiac cycle time is 0.8 second. Okay, that means atrial events also take 0.8 second because it's cyclical, it comes in cyclical manner, and ventricular events also take 0.8 second. First see the atrial events. Atrial systole, that is a contraction of the atria, is called the atrial systole. It takes 0.1 second. It is, and which is followed by the atrial diastole, and diastole time is 0.7 second, and again atrial systole will repeat. Okay, now ventricular events, again ventricular events 0.8 second, and ventricular systole it takes 0.3 second, and ventricular diastole it takes 0.5 second. Okay, now events under ventricular systoles are isometric contraction, maximum ejection phase, reduced ejection phase, and their time is mentioned, because in your answer every time you mention the time, how much time it's required out of 0.8 second. Okay, here it is 0.05 second, here it is 0.11 second, and here it is 0.14 second. Okay, now the events under the ventricular diastole. Okay, so total diastole, systole followed by the diastole, total time required 0.5 second, and 0.5 seconds divided into these 5 events occurring during diastole. The one is protodiastole, second is isometric relaxation, here it is isometric contraction, here it is isometric relaxation. Okay, then filling of the ventricles, the filling phase, because during the diastole uh, mainly ventricle receives the blood from atria, and that is called the filling phase. Filling phase is divided into three types: first rapid filling phase, slow filling phase, and last rapid filling phase. Okay, and also mention their time, because here some figures are odd, but keep in mind, remember it, थोड़ा odd figures है but याद रखो. Here it is 0.4 second, then here it is point not 8 second, then 0.113 second, 0.167 second, and it is 0.1 second. So it's a time, okay, required for each event. Now we'll discuss in detail, take one by one and describe the events, okay. Here this is a diagram, students, and if you are able to draw this diagram, remember again, if you are able to draw this diagram, then you can write the answer from whole answer you can write from this diagram, okay. So how you can explain this diagram, you try to understand. In this diagram, here there are two circles are there, two rings are there, okay. Here see the two rings, outer ring and inner ring, okay. So here how to draw, so I will just give you idea how to draw it, okay. So it is very simple to draw. You have to draw two circles or two rings. So inner ring, okay, this is one ring, inner ring, and see this is outer ring, okay. So ये inner ring हो गया, so outer ring हो गया, okay. So हमारा ये is just diagram is not ideal, but you just try to how to draw it. These are two rings, okay. Now you know our cardiac cycle time is 0.8 second. So divide these two rings into 8 total 8 equal divisions, okay. So how will you draw it? First you keep plus sign, यहाँ एक ऐसा plus sign करो, then keep one cross sign, okay. So one plus or one cross. So here like this, one plus one cross, one plus sign and second cross sign. So it gets divided into 8 equal division, 1 2 3 4 5 6 7 and 8 divisions, okay. And if it is divided into 8 equal division, means one division is 0.1 second, okay. So this is 1 second, 0.1 second, 0.1 second, 0.1 second, like this it is divided, okay. So it's a simple way to draw it, okay. Second, what you have to do, label it properly, okay. Labeling is properly, and then you can easily write the answer. So labeling is, suppose if you see the inner circle, here it's atrial systole, 1 second I just told, it takes 1.1 second, and it is followed by the atrial diastole, okay. So inner ring, it represents the events occurring in atria, and outer ring, it represents the events occurring in ventricle, okay. Now see the inner ring, first there is atrial systole and it is followed by the atrial diastole, okay. Then atrial systole is followed by the ventricular systole and it takes 0.5 second, okay. So यहाँ से लेके यहाँ तक it is ventricular systole, and ventricular systole is followed by the ventricular diastole, and there are the 5 divisions or 0.5 second is required. So ventricular diastole, like this inner circle and outer circle is there, okay. Now see the labeling, label it, after atrial systole, here the first heart sound it comes, it is due to the closure of AV valves, okay. Then first event is isometric, that is after atrial systole you go to the ventricular systole, and in ventricular systole first event is, just I told you the list, first event is isometric contraction. It is here at the end of the isometric contraction, here the cellular walls it opens, then it is maximum ejection, and initially maximum ejection, that is ejection of the blood to the circulation, and then it is reduced ejection to the circulation, that is to the aorta and pulmonary artery, okay. Here it is end of systole, that is a ventricular systole, and beginning of ventricular diastole. Okay, see student, in ventricular diastole labeling, uh, from this point to the this point, यहाँ से diastole शुरू हो गया है, तो this is the protodiastole. Okay, and here semilunar wall close. You know the cause of second heart sound is closure of semilunar wall, sudden closure of semilunar wall. Okay, then it is followed by the isometric relaxation. Okay, and here up to this point is isometric relaxation. Here AV walls, atrioventricular walls open. Okay, and this is a cause of third heart sound. I will again explain. Just labeling कैसे देखो, यहाँ सेमिलुनर एवी वाल्स ओपन हो गया, यहाँ से लेके यहाँ तक once the AV valve open, blood it is rushed into the ventricle and it is a filling phase. The first rapid filling phase is a cause of third heart sound. It is a first rapid filling phase. Then after that there is a slow filling phase because it is a brief period, बहुत ज़्यादा time है, and blood is coming from atria to the ventricles. Okay, and then at the end of this diastole, okay, यहाँ भी diastole है, and this is the last phase of the filling, that is called the last rapid filling phase, and here the diastole it ends. Okay, so like this labeling karo, and if you label it then start explain it. Okay, so explanation is very simple. Okay, first the atrial diastole. Okay, sorry, you start explanation from the atrial systole. Give the heading first, atrial events. Under atrial event there is a atrial systole, and you know atrial systole initiates the cycle as the AV node is located on right atrium. You know AV node means pacemaker, it is located on the right atrium, and once the impulse is generated, the first event it occurs, that is a contraction of the atria. Okay, and it takes 0.1 second, and then it is followed by the atrial diastole. Okay, it takes 0.7 second, and here you know at the end of atrial diastole, again atrial systole starts, returns. Okay, and in this way atrial cycle it goes on. Okay, and it takes 0.8 second. Okay, then you know at the end of atrial systole, ventricular systole starts, and the ventricular systole takes 0.3 second. Okay, then this is followed by the ventricular diastole and it takes 0.5 second. Okay, 0.3 second, 0.5 seconds, and in this way the cycle it repeats. So at the end of diastole of ventricle, the diastole ends, and in this way cycle it repeats and cycle goes on. Okay, so in this way cycle it goes on. Okay, now we'll continue. Take these headings one by one, take the events and explain it. Okay, now first see the inner ring I told. Now see the outer ring, and outer ring I told, and see the events. Okay, so first we'll continue with ventricular systole and we'll see the explanation in detail. Okay, here you know at the beginning of ventricular systole there is a brief, at the beginning of ventricular systole there is a brief period during which the both walls are closed and ventricles are contracting as a closed cavity. Okay, so here students try to understand at the beginning of ventricular systole the AV valves get it closed. Immediately AV valves get it closed and it causes, and due to the closure of the UV valves. As soon as ventricles start contracting, the pressure in the ventricle it increases and it causes the closure of the UV valves, produce the sound, and it is called the first heart sound. Okay, so here there is a brief period. That means here the EV valve is closed, but semilunar valve is not yet open. Okay, and it takes time. So when it will open, when the pressure in the ventricle it increases above the aorta and pulmonary artery, then only semilunar valve it opens. Okay, so from the closure of EV valves, it takes time to open the semilunar valve, and this period is called the isometric contraction. So what is the meaning of isometric contraction? During this period, there is no outflow of the blood or there is no inflow of the blood. Okay, blood bahar bhi nahi jata और अंदर भी नहीं आता. One thing. Second thing, no shortening of cardiac muscle, and hence it is called the isometric contraction. What is isometric? Iso means same. So length remains same. There is no change in length of the muscle. Length remains same, and that's why this type of the contraction is called the isometric contraction. So contraction is there. There is increase in pressure in the ventricle. There is increase in tension in the ventricle, but the length of ventricular wall remains same. That's why it is called the isometric contraction. Okay, and in this way you have to explain first event, that is the isometric contraction. Okay, now see, coming to the ejection phase. Okay, now here ventricle contraction begins, and after some time the semilunar valve it opens and ejection phase is started. Okay, ejection phase is started. So we can say that as soon as the pressure in the ventricle it increases above the aorta and pulmonary artery, the semilunar valves, that is aortic valve and pulmonary valves, get open, and ventricle eject the blood, pump the blood into circulation. Okay, so initially the circulation, that is ejection, is maximum. Okay, and that's why it is called the maximum ejection phase. Okay, और ये थोड़ा बड़ा है, 0.11 second it takes. Okay, now it is followed by the reduced ejection. Reduced ejection means in second half of the ejection the rate of outflow it slightly decreases, and that's why it is called the reduced ejection. Okay, and here this is the end of ejection phase. Up to this point it's the end of ejection phase, or it is the end of systole. यहाँ systole का end हो गया, and beginning of the diastole. Okay, now see the events occurring during the diastole. Okay, here diastole I told that it is 0.5 second total, and the 5 divisions are there. Okay, so यहाँ से लेके यहाँ तक is a diastole. Here as soon as the ventricle relax, the intraventricular pressure starts falling. That is, the pressure in the ventricle starts falling, because during the relaxation what happens is ventricles start relaxing and the pressure in the ventricle start decreasing. Okay, and when the pressure is decreased sufficient, then there is a sudden closure of aortic valve and pulmonary valve, because these valves prevent the backflow from aorta to the ventricle. Okay, and here it leads into the sudden closure of the AV valves. Okay, here the sudden closure of the AV valve produce the sound, and that is called the second heart sound. Okay, but see the students, from the beginning of the diastole and till to the closure of semilunar valve, there is a brief period, that is about 0.04 second. Means semilunar valve takes time to close, and that period is called the protodiastole. So protodiastole, it is a period between the onset of diastole to the closure of semilunar wall is called the protodiastole. This period is called the protodiastole. Okay. Now students, here uh, we'll go to the isometric relaxation phase. Okay, it is opposite to the isometric contraction. Okay, isometric relaxation means here relaxation is of the ventricle, but there is no lengthening of the muscle. There is no, here there is no shortening of the muscle length remains same. Here there is no lengthening of the muscle, because even there is a relaxation of ventricular muscle, the length of the muscle it remains same. Okay, but there is decrease in tension, there is decrease in pressure in the ventricle. Okay, so here from this period, here uh, semilunar wall is closed, but AV wall is not open, and this is a period from the closure of semilunar wall to the time is required to open the AV wall, and this period is called the isometric relaxation. Again we can say that both walls are closed. Here also the both walls are closed. Here also the both walls are closed, and ventricles are relaxing as a closed cavity. Means there is no outflow of the blood, there is no inflow of the blood, and that's why there is no change in length of the muscle. Only the pressure it falls, and this period is called the isometric relaxation, and this time required is 0.08 second. Okay, so we reach up to this point, and as soon as the sufficient pressure falls in the ventricle, then atrioventricular walls, AV walls, that is mitral wall and tricuspid walls, get open. Okay, and if these walls open, the blood suddenly it rushes or passes from atria to the ventricle, and due to the rushing of this blood from atria to the ventricle, it produces the sound, and that is called the third heart sound. So what is the cause of third heart sound? The sudden rushing of the blood from atria to the ventricle produces the sound, and that sound is called third heart sound. Okay, so students, we can say that here uh, if you start from this point, the closure of the EV valve indicates the beginning of systole, and the closure of semilunar valve it indicates the end of ventricular systole and the beginning of ventricular diastole. And here opening of semilunar valve, it leads into the blood, it rushes from atria to the ventricle and produce the third heart sound. So this is a cause of third heart sound. Okay, now see, filling of the ventricle it begins. Okay, and as soon as the AV valves open, initially blood the flowing of the blood from atria to the ventricle is rapid. There is a rapid filling of the ventricle, and that's why it is called the first rapid filling phase. Okay, so first rapid filling phase, it is time required is 0.113 second, and the blood flow to the ventricle is high, ज़्यादा है, maximum है, that's why it is called the rapid filling phase. Okay, then rapid filling phase, it is followed by the slow filling phase. Okay, so this phase of ventricular diastole, due to the pressure falls, so during this period the pressure fall in the ventricle, here the pressure falls in the ventricle, and accumulated blood of the atria rushes into the ventricle. It is called the first heart sound. Okay, and this rapid rush it produces the third heart sound. So students, the second phase, we'll talking about the second phase. Here it is the longest phase of the ventricular diastole. Okay, and here the amount of filling is maximum. okay, because its a period is more, okay, and the rate of filling of the ventricle slow down because ventricles are already full and the pressure rises slowly, okay. If the pressure rises slowly, the filling is slowed down, and that's why it is called the slow filling phase, okay. Now the slow filling phase is followed by the last rapid filling phase. So last part of the diastole is the last rapid filling phase, and this phase of the ventricle, it corresponds with the atrial systole, okay. Here it corresponds with the atrial systole, and due to the atrial contraction, the blood from the atria rushes into the ventricle, and that's why it is called the last rapid filling phase. So what happens is here, it is corresponds with the atrial systole, atrial contraction. Atria it pumps the blood into the ventricle, and that's why it is called the last rapid filling phase. Students, in this phase, due to the contraction of the atria, the remaining blood, because the filling it starts from this point, but whatever the remaining blood or accumulated blood at the end of the diastole, due to the contraction of the atria pumps it into the ventricle, and due to this rushing of the blood, it again produces the very low intensity sound, and that is called the fourth heart sound. So what is cause of fourth heart sound? The uh, the last rushing or during the last rapid filling phase, due to the contraction of the atria pumps blood into the circulation, and this rush of the blood, it produces the sound, and that is called the fourth heart sound, okay. Students, here the ventricular diastole end, okay, ventricular diastole end. Meantime, the impulse arrives from the pacemaker, that is the SA node, causes the ventricular systole, and here at the meanwhile the impulse is produced by the SA node, and it leads into the atrial contraction followed by the ventricular contraction, that is a ventricular systole, and in this way the cycle goes on throughout the life, okay. So students, up to this point we discuss how the events occurring in the ventricle and the atrial events, ventricular events, and in this way you have to explain one by one, okay. So up to this point, students, we can say that it is a first half of the lecture, okay, and now we'll enter to the second half. We'll continue here, see what is there in the second half. So these points already we discussed, okay. Okay. In the second half, we have to study the pressure and volume changes occurring during the cardiac cycle. Okay, so we'll stop here, student, and in the next class, we'll continue this pressure and volume changes occurring during the cardiac cycle, okay. Students, at the end again I want to tell you that suppose if the question is I just told the questions, the describe the pressure, describe the events occurring during the cardiac cycle. So you explain what events we just studied, and it is followed by the pressure and volume changes, okay. I think you followed it, and we'll stop here, okay. Bye bye.